Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to demonstrate how to apply the law of sines to find the sides, missing sides of a non-right triangle. So this is number, I think, 10 in the current trig book we're using, and not the best picture I've ever drawn, but it's good enough. We have a triangle. Humor me, these are perfectly straight lines. And we've got an angle of 40, another one of 45, an interior angle C that we'll find shortly, and sides A and B that we're going to look for. All right, first of all, let's talk about C. Let's go ahead and use this fact that in Euclidean geometry, the three angles within a triangle have to add to 180 degrees. So that means C plus 40 plus 45 is equal to 180. So C is going to equal 180 minus 40 minus 45. I believe that's 95 degrees. Known angle. Now to find sides A and B. So I'm going to apply law of sines to find side A. I'm going to start by taking note that I now have a side and its angle opposite. So we can say that 4 over the sine of 95 degrees is equal to the side A divided by the sine of 45 degrees. Now, depending on where you look up law of sines, sometimes it's written like side of A over A equals side B over B, side C over C. Other times it's written A over sine A equals. This doesn't matter. Because these things are equal, the reciprocals are also equal. You can write it like this or like this. Oops, actually, I'm sorry, these are supposed to be like lower A, lower B, lower A, lower B. When the ratios are equal, the reciprocals are also equal. Boy, this is kind of crummy, but we'll get rid of that. So you can write this 4 over sine 95 equals A over sine 45. Alternatively, you could write it sine 95 over 4 equals sine 45 over A. I usually write it so that the unknown is in the top. That leaves you with one less algebra step to solve it. So this can be solved by multiplying both sides by the sine of 45 degrees. So we're going to have A equals 4 times sine 45 over sine 95. Would somebody take a calculator and run a value, please?
I got 2.8.
2.8 degrees, okay. Now, one of the things you may be used to from applying right angle trigonometry is finding a side and then using Pythagorean theorem. I would warn you, you cannot do this here. Pythagorean theorem does not apply to non-right triangles. So to find B, what we can do is apply law of sines again. B over 4 is equal to, whoops, I'm sorry. I gotta go back, my bad. B over sine 40, that's what I meant, is equal to, let's see here, how about 4 over sine 95? Could have also used the side A, 2.A over sine 45. You can use either one. So B is going to equal 4 times the sine of 40 degrees divided by the sine of 95 degrees. Would somebody run a number, please?
I got 2.6.
2.6. And we now have both sides in the inner angle for this triangle. So this example's done. I think I'll just leave this video at that and make another one for the next example. Have a great day.